Welcome to our YouTube channel students, e-learning hub by Udgam Welfare Foundation. Students, in this video series we are going to discuss the case studies on the chapter differentiability and continuity for grade 12 students. These case studies will be very helpful whether you are a CBSE student or whether you are a ISC board student. We are going to discuss various concepts in these different case studies so that it is going to enhance your skill how to tackle these case study in your coming board exams. So let's move forward and first discuss about our first case study here. So student, this is our first case study where it states Rahul, a student of grade 12 student, is interning a robotics startup where he has been asked to study how the robotic arm's motion changes with temperature. The angle theta of t in radians made by the robotic arm at any time t is differentiable function of time and temperature t affects the speed of its movement, that is theta also indirectly depend on temperature through time. The function theta is given by theta of t is equal to log of cos t and t of t is equal to 2t plus 5. That means this function is in t. Rahul wants to study how the angular speed, that is d theta by dt, changes over time and how this relates to the continuity and differentiability of composite functions. Based on his findings, he notices that some values of t cause the function to become undefined. He decides to analyze the continuity and differentiability of such composite expressions, including identifying where the functions may break or behave unexpectedly due to domain restrictions. Let's explore some questions based on Rahul's observation. So on the basis of this case study, I have prepared 5 MCQs as per the board standards so that it is going to enhance your skill to tackle these case studies. So let's move forward and first discuss about first question on this case study. So student, this is our first question which states for the function theta of t is equal to ln cos t, that is log cos t. Which of the following time intervals ensures that theta of t is defined and continuous? Obviously, when we are discussing a logarithmic function, that means log of x. So x is always greater than 0. So we have to restrict the value of cos t so that it will be a positive function. So we can say that log of cos t is positive in the first quadrant as well as in the fourth quadrant. So if we see that t belongs to 0 to pi by 2 and t belongs to 3 pi by 2 to 2 pi are the two options correct here in this particular question. Now let's move forward and discuss about the second question. So student, this is our second question which states what is the derivative d theta by dt if theta of t is equal to ln cos t. Very simple. So if we derive this, or we can say that if we find d theta by dt, that is with respect to t we are derivating, so we are going to get log of cos t. So log of x is what? 1 by x. Very simple. So first write 1 upon cos t into derivative of cos t is what? Minus sin t. So it is going to give you minus of tan t. Very simple. So where is our answer? So option B is our correct answer here. Now let's move towards question number 3. So students, here comes our question number 3. Which of the following functions is differentiable for all real numbers? So first understand fx equals to log x, as we have already discussed. The derivative of this is minus tan t, or we can say that minus sin t over cos t. If this is 0, then the function is not defined. Now comes fx equals to tan inverse x. The derivative of tan inverse x is 1 upon 1 plus x square. So here we can say that this function is defined for all real values here. So our answer is what? Our answer is tan inverse x is the correct option here, because if we discuss about this sec x, the derivative of sec x or the function is not defined on 1 over cos x, that is again it is not defined on 0. Very simple. Similarly, this function is also not defined on what? this function is also not defined on when cos x equal to 0, we can say. Now let's move towards question number 4. So here comes our question number 4. Let fx equals to log of cos x and gx equals to this. So what is derivative of f of g of x? So here we have to make the composite function. That means we have to make f of g of x. That means our function will be ln cos of 2x plus 5. Very simple. So this is our function which we need to differentiate here. So we are going to differentiate this. So it will become 1 upon cos 2x plus 5 into minus sine of 2x plus 5 into derivative of 2x plus 5 is what? 2. So our answer is basically minus 2 tan 2x plus 5. If we are going to simplify this, then we are going to get what? Minus 2 tan 2x plus 5. So this is our answer. So option number A is the correct answer here. Now let's move towards question number 5. So students, here comes our question number 5, which states fx equals to ln cos x. Which of the following statement is true regarding this particular function? So is it continuous for all real numbers? No, it is not, because we have already discussed this. When this is less than 0, then the function is not continuous. Is it discontinuous at x equals to pi by 2 plus n pi? So we have to look at this, because this function, when it becomes 0, and due to this it becomes negative. So whenever this function will be 0 and less than 0, this function is not defined. So which of the following statement is true? It is discontinuous at x equals to pi by 2 plus n pi here. So students, that was the last question of this case study. Hope you enjoyed this particular video, and if you like to do online test on different chapters which is going to target your 1 marker question in board exam, so I have prepared the online test on my website, which is udgamwelfarefoundation.com, which is available free of cost to every student. It is going to help you out in how to tackle the 1 marker question in board exam, and obviously it is going to enhance your skill on various chapter. So I am going to share the link in the description box so that you can easily access those MCQ questions on our website. So that was all in this particular video. We are going to meet in our next video. Till then, goodbye and take care.